Okay, so today we're going to talk about finding the area of regular polygons. And so this is going to be, this is going to be a two-part video. We're going to talk about composite figures afterwards, but just looking at regular polygons to start off with. So how we find the area of a regular polygon is we use this lovely formula here. And what this lovely formula tells us is that the area of a regular polygon is going to be half the apothem times the perimeter. So in order to calculate this, all we really need is a side length, and we can find the rest. So anyway, that being said, let's get into it. So half the apothem times the perimeter. And the apothem is, it starts at the center of the figure, and then it's a line that goes from the center to one of the sides, and it intersects the side at a 90-degree angle, which, hint, hint, is going to give us a special, or a right triangle, I should say. So, that being said, let's get to it. So, we need to find the area of this regular hexagon, and we need to round to the nearest tenth. So, first things first, I know we need to find the apothem length. I know that's something we need to do. And in order to do that, I need to figure out what the angles of this little right triangle here is. And I think immediately to, okay, well, this line, since it is going from the corner to the center, since all of these are going to the center, they're all going to be angle bisectors. And I know one interior angle on a hexagon is 120 degrees. And of course, I can calculate that by saying, okay, a hexagon has 6 sides, 6 minus 2 times 180 divided by 6. And I could plug that in my calculator, and I would get 720 over 6, which would be 120 degrees. But I've done enough polygon work that I just know that off the top of my head. And once again, it's going to be half of that because PR bisects that angle. And so we have a 60-degree angle here. Now, I know if I have a 60-degree and a 90-degree, then the remaining angle is a 30-degree angle. And fortunately, or unfortunately, depending on your point of view, I know there are special rules for 30, 60, 90 triangles. So I know this bottom side here is going to be half of 5, so it's going to be 2.5. I know this up here is going to be 5. And then that means that my apothem is going to be 2.5 root 3, based on those special right triangles that we've been dealing with for a while now. So now that I know what my apothem equals, I can plug all my information into this formula. The area equals 1/2 apothem times perimeter that we got from this first page. So my apothem, of course, being 2.5 root 3. And then my perimeter, since each side is going to be 5, since a regular polygon is the same size, same shape. All the angles are congruent to each other, and then all the side lengths are congruent to each other as well. So that means each one of these has to be 5 as well. And 5 times 6 would be 30, so my perimeter is going to be 30. Now I can just go about plugging this in my calculator. So I can say 2.5 root 3, and then I'm going to multiply that by 30 and divide that by 2. So I would get an area of 64.95 meters squared. That's how I'd find the area of that, which is delightful. The good news is hexagons are moderately simple, straightforward, since they're going to be 30, 60, 90 triangles on the inside. Not all shapes are going to be that simple, which is unfortunate. here's a prime example of that. So we have a pentagon here. So for this pentagon, we're going to have to do just a little bit more work than we'd probably like to. But that's all right because we're up to it. So first things first, what I would like to do is just go ahead and find out what each interior angle is, just for my own happiness. And so how I'm going to do that is I'm going to use that same formula. So I'm going to say 5 minus 2 times 180 divided by 5. So I'm going to have 540 divided by 5, which I believe should be 108 for interior angles. That's not what we were looking for, eh? Oh, it is. I lied. Okay. Where am I at here? I am losing my mind. Delightful. Okay. So, what we're going to do now is we Alright, so what we're going to do is we are going to try to find the apothem, and we are going to try to find the side length of AB. So first things first, we want to operate in this lovely little triangle here that I'm just going to highlight in black. So we're operating within that triangle. Now, we know half of 108 is going to be 54 degrees, which means the other side has to be 36 degrees. Now, we can use this to find the side length for DB. So what I would say is using SOHCAHTOA, if we remember SOHCAHTOA, it wasn't that long ago. We're going to be using a lot of stuff that we learned a while ago, and so this is where it really comes in handy to have good notes. And I want the opposite side and the hypotenuse, so I'm going to use sine of 36 is going to be my opposite, x over my hypotenuse of 9. Now to solve that, I would say 9 sine 36. And I could say that dB is going to be about 5.29. We're just going to round just for happiness' sake. And if we wanted, we could do the same thing with 54 to find the missing side of CD. Personally, what I'm going to do is I'm just going to square my answer I just got. And I'm going to do 81 minus that answer equals, and then square root, second answer. And I get 7.28 for my apothem length. And what I was doing there was I was using Pythagorean theorem. So I was saying 9 squared minus 5.29 squared is going to equal CD squared, which then I took the square root of, and I got 7.28. So now we have almost all the information we need in order to solve this. And the only missing piece is we need to know the length of AB, which is of course going to be just 2 times 5.29. So I would get 10.58. And then I would of course multiply that by 5 since there's 5 sides. So 10.58 times 5 equals 552.9, and then I need to multiply that times my apothem, which is going to be 7.28, and now that I'm going to divide by 2 or multiply by 1/2, depending on how you choose to go about this. And our answer is going to be about 192.6, we'll say. centimeters squared. So it's a lot of steps. It can be a serious challenge. I'm well aware of that. However, that being said, I know you are all up to the challenge. So continuing on, this is where you would solve this one on your own. We'll just let that one be for now. So that would be 7.5, which would mean 7.5 squared divided by, or 7.5 squared minus 3.5, 3.75 squared is going to equal that. Second square root, second answer. It's going to be that. So that's my apothem times 7.5 times 6 equals divided by 2. So correct answer is going to be D, in case you wanted to work that out on your own. Okay, second thing we're going to be talking about today is composite figures, and you will find that in the